Hello, I'm launching a series of videos about graph rendering in Grafana. In the first video, we'll try to understand how Grafana translates our queries into the data points we see on the screen. I'll cover the basic concepts that determine how graphs are ultimately displayed. The main focus will be on how to control the spacing between data points on a graph. For example, in this graph, you can see that there's a 15-second interval between each data point. Before we dive into the details, it's worth noting that the flexibility you have in controlling the spacing between data points on a graph varies, depending on the data source. For example, there's a difference between a Prometheus data source and an SQL data source. In this video, I'll focus on Prometheus as the data source. In the next video, we'll look at SQL as our data source instead. Let's take a look at the query we're running against Prometheus. This is a very basic query. It uses the rate function on the Windows CPU time total metric. Since this is a counter metric, we need to use the rate function, which I've configured to calculate the rate over a 1-minute window. I've also added a filter to keep the graph's visualization as simple and focused as possible. I'll click the Query Options button so we can take a look at the settings that are relevant to how the graph is rendered. The most fundamental concept when it comes to controlling the graph's appearance is the interval. It's a read-only value, and ultimately, it determines the spacing between the data points on the graph. As you can see in our graph, there's a 15-second interval between each data point, which matches the value shown in the interval field. The next two relevant settings are min interval and max data points. So, how is the interval determined? Let's focus on the tooltip, and I'll try to explain. Grafana first calculates the interval automatically based on the selected time range and the max data point setting. This isn't an exact mathematical calculation. It rounds the result to a practical time interval, such as 5 seconds, 15 seconds, or 1 minute. Once that calculation is complete, Grafana compares the calculated interval to the min interval. If the calculated interval is smaller than the min interval, Grafana uses the min interval instead. Otherwise, it uses the calculated interval. Let's look at a couple of practical examples. We'll set max data points to 300. Our graph's time range is 5 minutes or 300 seconds. If we divide 300 seconds by 300, we get 1 second. Since the min interval is set to 15 seconds, which is larger than the calculated interval, Grafana uses 15 seconds instead. Let's apply the change in practice. Notice that even after updating max data points to 300, and refreshing the page, the value in the interval field remains at 15 seconds. Let's take a look at the data points on the graph. As you can see, the spacing between the data points on the graph also stays the same. The value in the interval field remains at 15 seconds, and again, this is because in this case, it cannot go below the min interval. If we take a simplified view of the calculation, 300 seconds time range divided by 300 max data points gives us 1 second. But Grafana then applies rounding, and a min interval wins and overrides the result. So the final interval is still 15 seconds. Now let's change max data points to 10. This time, 300 seconds divided by 10 gives us 30 seconds, which is greater than the min interval. As a result, Grafana uses 30 seconds as the interval. It now uses a 30-second step, so the graph displays a data point every 30 seconds. I now want to talk about the option to override the interval setting. This is located in the Query section under Options. It is called min step. We have now reverted to the default settings in the Query Options. The interval is set to 15 seconds. Max data points is left at its default value. The min step is set to auto, as you can see, which is its default setting. Now let's change the min step value to 5 seconds, refresh the dashboard, and see what happens. As you can see on the graph, the interval between each data point is now 5 seconds, which is the value we configured in min step. In other words, this setting has effectively overridden the default interval setting of 15 seconds. Now, let's change the min step value to 60 seconds, refresh the graph, and see what happens. As you can see, the interval between the data points is now 60 seconds. This confirms that min step has once again overridden the default interval setting. Now, let's look at a different scenario. We will reset the min step setting back to auto. After refreshing the graph, we can see that everything is displayed according to the default settings, with a 15-second interval between each data point. Next, we will go into the query options and change the default settings. We will set the max data points value to 10. Once we refresh the graph, we can see what happens. This, of course, is the expected behavior. The number of points on the graph is reduced based on the new interval created by dividing the time range by the max data points, which results in 30 seconds, exactly as we saw before. Now, let's change the min step value to 5 seconds and refresh the graph to see the result. Notice that, in this case, the 5-second value in the min step does not override the value in the interval. The reason for this is that Grafana's algorithm seemingly prioritizes the constraints set by the max data points limit. In this situation, it appears that the min step configuration becomes effectively meaningless. To get a more complete picture, I'd like us to review the Prometheus configuration file. At the moment, the default setting in Grafana is a 15-second interval for graph visualization. However, the default scrape interval in Prometheus for all exporters is configured to 30 seconds, and this value is not overridden in the relevant job. In other words, there is no direct relationship between the scrape interval configured in Prometheus and the interval configured in Grafana. The Grafana interval setting does not affect how frequently Prometheus collects metrics. It only affects the query resolution and how the data is displayed in Grafana. We are now looking directly at Prometheus itself, displaying the scrape results for exactly 1 minute for the relevant metric. As you can see, there are exactly 2 metric samples, spaced 30 seconds apart. The next question is, how does Prometheus return results every 15 seconds when requested by Grafana? As we've seen, Prometheus stores samples for this metric at a 30-second resolution. The answer is that when Prometheus receives an API request with a resolution that differs from the stored sample resolution, it evaluates the query at each requested timestamp and computes the corresponding results based on the available samples. In our case, if Grafana requests more than 2 results over a 1-minute period, Prometheus returns the relevant results, even though only 2 original samples were actually scraped. The additional results are computed by Prometheus during query evaluation rather than representing newly collected samples. Let's take a look at what Grafana's API request to Prometheus looks like behind the scenes. For simplicity, I've left the query options at their default settings, which means a 15-second interval, and I've set the time range to 1 minute. Next, we can open the query inspector. Then, refresh the view. As you can see, the query inspector displays both the requests sent by Grafana and the response returned by Prometheus. You can inspect the query parameters that were sent, as well as the relevant data returned by Prometheus. If you'd like to explore this in more detail, I encourage you to take a deeper look at how the interaction between these 2 systems works. See you in the next video.